Section 4.5, Exponential and Logarithmic Equations, Part 1. In this part of the notes, we're going to focus on exponential equations. A property that we're going to use to solve these exponential equations is the following. If x is greater than 0, y is greater than 0, a is greater than 0, and a is not 1, then the following holds. X equals y is equivalent to log base a of x equals log base a of y. The reason this is important is because in this concept, we're going to have exponents on our x and y. So we'll have exponents up here with a variable in them that we want to solve for. Well, the only way, I guess I would start over here, the only way for us to get those exponents down is going to be to take a log of both the x and the y term and then bring those exponents out front. Remember that power rule that we had, where if we have log of a term with an exponent, we can bring that exponent out front, just like I moved the m out front here. So that's going to kind of be our goal here. We're going to take our exponential equations and we're going to take a log of both sides, and then that's going to bring our exponents down so we can solve for our variables. Example 1, we're going to solve the equation 3 times 0.7 to the x minus 15 equals 30. So the first thing that we're going to do here is we're going to get rid of that 3 out front so that we just have our base with our exponent. Okay, so now that we have on the left side just a base with an exponent, we can log both sides of this equation so that we can bring our exponent down out front. I could technically take any log base I wanted to. I could take log base 5 on both sides. I could take log base 3. I could just take the common log, which is log base 10. I'm going to use the natural log because it's an easy button on my calculator. So we're going to take the natural log of both sides. Remember, if we do something to one side, we've got to do it to the other. And now at this point, I can take that exponent of x minus 15 using our power rule, and I can bring it out front of the natural log. Okay, now that we have that out front, let's move the natural log of 0.7 to the other side of the equation. It's attached to the x minus 15 by multiplication, so I'm going to divide both sides by ln of 0.7. So we just have x minus 15 left on the left side. And then our last step to get x alone is going to be to add 15 over to the right side. And at this point, we can pick up our calculator and type that in and make sure we round it to the nearest hundredth. Excuse me, to the nearest thousandths. Example 2, solve the equation 3 to the 2x minus 1 equals 0.4 to the x plus 2. In previous parts of chapter 4, we would take an equation that looked like this and try to rewrite it with common bases. We would take 3 and 0.4 and try to rewrite them, but we can't do that in this situation. So what we're going to do is we're going to take the natural log of both sides of the equation so that we can bring our exponents out front. So with our power rule, we can bring our exponents out front of each of the natural logs. From here, we're going to distribute each of those natural logs into the parentheses, and then we're going to have to rearrange terms so that we have both of our x terms on one side of the equation and our two constants on the other side. So now that we've distributed both logs in, let's look and see where our two x terms are and where our two constant terms are. So here's the two terms that have x in them. We're going to want those to be on the same side of the equation together. And then in orange, we have the two terms that don't have x. So we're going to want those to be on the opposite side. So let's move our two orange terms to the right side. So we're going to be adding ln of 3 over to the right side. And then let's move our x terms, our green ones, over to the left side. So we're going to be subtracting x ln of 0.4 over to the left side. You could do this in two separate steps. I've just done it all in one step. Okay, now that we have our x's on the left side, what we're going to do is we're going to pull out a greatest common factor of x from the left side. So we're going to pull an x out of both of these terms. And so we'll just have one x at that point. So here's the x we're going to pull out. Rewrite both of those terms without the x now. And now the last thing we need to do to get x alone is to divide the quantity that it's being multiplied by. So we're going to divide both sides by 2 ln of 3 minus ln of 0.4. So in the end, we get x equals this quantity, and now we can pick up our calculator and type that in. Notice on all these problems, we don't use our calculator midway. We just wait till the very end, and then we type that in. Example 3, part A. Now we're going to solve equations that involve base e. So we have e to the x squared equals 200. Just like before, we're going to take the natural log of both sides, but this time it's going to be kind of nice because the natural log and the e are going to cancel out because they are inverses of each other. So on the left side, we get just x squared. Again, that's because natural log and base e are inverses and they cancel each other out. Now we can square root both sides. Remember, anytime we take an even root, so in this case we took a square root, anytime we take an even root, we need to put a plus minus in front of our answer.